Children, now we are going to learn about enthalpy. Enthalpy, the formula is H, the letter H. It is a thermodynamic property of a system. It is defined as the sum of H, enthalpy defined as sum of the internal energy and the product of pressure and volume of the system. Sum of the internal energy and the product of pressure and volume. So H is equal to U plus PV. Enthalpy is a state function which depends on the state functions T, temperature, pressure and U internal energy. Enthalpy is usually expressed as change in enthalpy, that is delta H. So for a process between initial and the final states. So del H is equal to del U, change in internal energy, plus pressure kept constant, and del V, change in volume. So the change in enthalpy is equal to the heat supplied. Del H is equal to the heat supplied at the constant pressure. So there are two type of reactions due to heat. One is endothermic, the other one is exothermic. In endothermic, heat absorbed by the system from the surrounding. Heat absorbed by the system from the surrounding. So Q greater than 0 having positive value. Exothermic, heat is evolved by the system to the surroundings. Heat evolved to the surroundings by the system. That is Q less than 0 having a negative value. So if Q having positive value, del H also having a positive value. If Q is negative value, del H is also having negative value. So now we are going to learn relationship between enthalpy H and internal energy U. It's very important derivation. Enthalpy H and internal energy U. When the system at constant pressure undergoes a change from initial state to final state. So initial state H1, U1, V1 to a final state H2, U2, V2. So, how will you write for enthalpy? Already you know the definition. H is equal to U plus PV. In the initial state, H1 is equal to U1 plus P into V1, first equation. Final state, H2 is equal to U2 plus P into V2, second equation. So change in enthalpy 2 minus 1. 2 minus 1. So H2 minus H1 equals to U2 minus U1 plus P into V2 minus V1. So this is del H equal to del U plus P into del V. Here as per the first law of thermodynamics, del U value is Q plus W. Substitute this value here. So del H is equal to Q plus W plus P delta V. W value minus P delta V. Substitute here. So del H is equal to Q minus P delta V plus P delta V. Get cancelled. So therefore del H is equal to Q into P at constant pressure. That is QP means heat absorbed at constant pressure and is considered as heat content. This is the relationship between H and U. You have to derive. Now consider a closed system having gases which are chemically reacting to form gaseous products at constant temperature and pressure with volume V initial and V final as the total volumes of the reactants and products, namely Ni and Nf, that's number of moles of gaseous reactant and products. So for reactants, that is initial state, ideal gas equation PVi equal to Ni RT, first equation. For the products, that is final state, PVF is equal to NF RT. Subtract the both. 2 minus 1. So P into Vf minus Vi is equal to Nf minus Ni into RT. That is P del V is equal to delta Ng, number of moles of final and initial del Ng into RT. So substituting this P del V into del Ng in equation, we are getting last equation in substituting the value of P delta V. So we are getting for internal energy del H is equal to del U plus delta Ng RT. Substituting here, del H is equal to del U plus P delta V. Substituting the P delta value, so del H is equal to del U plus P delta values del Ng RT. We are getting this value, final value. This derivation given in book page number 197, continued in page 198 also, very simple only. Children, you can go through. This is the initial, final, subtracting the both, we are getting this one. Now this is from first law of thermodynamics. Q value substituting, then W value substituting, getting the last. Then if the closed system having gases with constant temperature, so we are getting lastly change in enthalpy, we are getting the value del U plus del Ng RT.